Hello, I'm Dr. Ron England coming to you from Daytona State College, and this is CEN3722, Human-Computer Interaction, and we're wrapping it up with the final lecture of our entire lecture series, Advanced Interfaces. And we're going to talk about some of the advancements of where we're going with HCI and some of the things that we're going to be able to do. So part of this is we're going to be able to define some things like this concept of a multimodal interface. But the multimodal interface is now dealing with things that we traditionally wouldn't have had the capability, because we have things now like speech and understanding and artificial intelligence and handwriting recognition. Some really cool things coming up. And what we want to be able to do is really understand a little bit about where we can go, but some of the limitations that we have as we're moving there. Some of the limitations you're going to be dealing with will be technical. Some of the limitations that you're going to be dealing with are going to be human. And understanding both of those is going to be important to you to create successful interfaces. So the concept of a multimodal interface is just that. Use the other senses. If you've been designing computer interfaces, you've probably designed these graphical screens that they're visual. And you may throw in a few beeps or buzzes here, and now you've got a little auditory component. But there's other senses. Now, you may not necessarily be using the sense of smell that much, even though there are interfaces that do that, or the sense of taste very much, but you do have the sense of touch. That's also part of what you can do there. And it is possible to put multiple together. Let's first talk about speech. Speech is our natural form of communication is speech. Human to human, speech is pretty much it. There are other forms of communication besides speech. Okay? You do have the capability of having pure visual communication without the form of speech. But speech is really, really hard for machines. Humans do it quite well. And that is the way our brains are wired. They're wired to understand. But speech is complex. Speech has nuances. Machines don't like nuances. Humans have no problem with nuances. We deal with it very well. But beyond just the technical difficulties of being able to take speech, to take accents, to take the little ambiguities of speech and turn them even into the textual portion of speech is extremely challenging for machines, because people have inflections and they have accents and they don't say things in a logical fashion somehow. But the beauty of this is that humans can translate this, or I can say translates humans can. It is a thing of beauty. Same exact thing that I said before, but I said it completely differently, but it had the same meaning. Machines have a hard time of grasping that. Okay. But humans are able to put all that together. I can even say with left, okay, leaving words out, and you'll actually form a speech pattern from that. Okay. You may not get the same exact speech pattern that I intended. Humans are capable of leaving things out and still understanding what is being said. But many of you do have that capability. Now, when you're designing systems that are speech-based, and we are moving a lot towards systems that do have speech-based, realizing that speech is many times the visual communication of standard displays is still way more efficient than what you would get from a speech interface. But people that are disabled, or people that actually have to use their hands, or actually have to have visual focus on something, speech interfaces are good, okay? And it's not a bad idea to go ahead and design those types of interfaces. Synthesis of speech, which is getting much, much better and going to be getting better in the future, you know, they're still a little bit machine sounding. The point of creating a synthesized speech as an output is to actually get beyond that machine sounding, have something that's natural. People are very good at denoting inflection in speech. So something like saying, oh, don't touch that, you might get hurt, or don't touch that, you might get hurt. Besides the volume issues, the inflection issues are actually very important. I'll actually try this again without the volume, but with just the inflection. Don't touch that, you might get hurt. Don't touch that, you might get hurt. Okay? The difference in intonation actually conveys a level of meaning. Again, whenever you're dealing with something like that, it's very difficult for a machine to get that, reproduce it, or understand it, whereas humans are quite capable of doing it. Okay, but we are getting better. Remember, I'm talking about advanced interfaces. Where are we going? Now, of course, you can have the concept of the uninterrupted speech. The uninterrupted speech is, I just pre-record a message. Welcome to Daytona State College. I hope you have a great time here today. Whereas where you have the interrupted speech, where I've recorded, welcome to Daytona State College. I hope you have. Okay, you've heard those messages where they've actually patched together the different pieces. Those are actually human recorded segments, okay, but those human recorded segments are patched together. It also gives you a less than satisfying experience as you would get with a full flow of speech itself. Now, beyond speech, you've also got the concept of non-speech sound, which we've talked about quite a bit. Putting speech, visual, non-speech, and all that together, you can get a very rich capability of conveying a tremendous amount of information in a way that users can actually use and understand. Okay, it may be redundant, but remember, redundancy is not necessarily a bad thing, and redundancy in systems that are critical is actually very important to provide. So, even though we've been dealing with these user interfaces that are primary visual, don't forget that between non-speech and speech-based sound, you still got the ability to convey more information than you could with just the visual interface. So we're going to kind of move beyond that. Before we move on beyond non-speech sound, though, there's a couple small things that I want you to get from the speech. One is the concept of language and the concept of meaning. Okay, and this is a tough one to say, but different people translate things that you say in different ways. And they may translate things that are said by a computer in different ways. Those are things that you need to take into account. But when you're dealing with both the visual with the non-speech or visual with the speech, there are just specific parameters that you take into account. But you have that ability to convey good amounts of information. Status, okay, very quickly, level of critical, a ding versus a buzz, those are all things that you can convey with those, but you can convey those with the speech also, and you can get even more with both. Warning, warning, warning. Handwriting is also actually, now it's quite good. Now, in designing a system that actually has to deal with handwriting, these are becoming a little bit, we've gotten good with the technology, but we haven't necessarily gotten good with the requirement to use the technology. So handwriting systems themselves, we can capture good handwriting input, even though a lot of times handwriting is very difficult to bring into a computer. We do have systems that are very good at that. The acceptance of handwriting-based systems is really going to be more based upon people that would like to write versus type. And that kind of gets down to that pure human level of dealing with it. Computer vision is one of the fields that's going to give us a tremendous amount of capability and has already provided a tremendous amount of capability. Computers, humans see in a certain way. The sensory input that comes from our eyes goes to our brain, and our brain is incredibly good at processing it and turning it into meaning. When you're dealing with trying to process things into meaning, in a computer, it's much more difficult because computers don't process information the same way that a brain does. It's a serial processing versus a large-scale parallel processing. I mean, we have been able to do a very good job of training computers to recognize cats on the internet because there's lots of cats on the internet. But just having a computer recognize that is a cat, that is a dog, is a huge thing. Now, as you're dealing with the concept of designing for computer vision, Just the concept of saying, if I'm looking at something with a computer eyes, with a camera, and I'm trying to put into the computer exactly what it is that the computer is seeing, okay, that is a huge technological step. Then turning that input into something that then can be turned around and be used by a user, things like facial recognition and other things that go with that, well, now we've got some pretty good advances. But these are all things that are moving forward in the technology and are getting much better as time goes by. In designing these types of things, if you're designing for future systems, it's a good idea to think about, where are we going to be? What if this technology worked perfectly? What can I design for that type of technology? Ubiquitous computing, which is one of the things we're also moving to. We're not 100% ubiquitous. If I want to talk to my cell phone, I have to pick my cell phone up and hit a button. So it's not 100% ubiquitous. Ubiquitous would be, computer, can you take care of this? That's literally being everywhere at all the time, that I always have access to my computer no matter where I am. That's ubiquitous. But there are places in systems where ubiquitous computing does exist, and people are building houses that are ubiquitous computers, that the computer is built into the house. It has the visual and speech recognition capability. What does that mean? Well, it means you've now got something else that you can design for. And again, we're thinking about what it is, where are you going with design? If the computer knows where I am, and the computer can hear what I am saying, and the computer knows what my intentions are, I can have a very useful system. I can create good user experiences. I can also create bad user experiences. Okay, great. We would rather do the good user experiences. Now, these different types of multimodal inputs they're coming around, they're more and more accepted over time, and they're going to continue to be more and more accepted, but there are a special place where they really do exist right now, and that is important, and that is users with specific special needs. People that are sight or hearing impaired, these interfaces are crucial to those people because they allow them to use systems that the rest of us take for granted and be able to use them in a relatively natural setting. Now we're going to move a little bit beyond some of the systems, and we're kind of now stepping into the present and the future. One of the things that we've got now that is a big field is the field of virtual reality. And if you really do like putting on clunky headsets and working in a virtual world, virtual reality brings about an entire new branch of HCI. The ability to work in 3 full dimensions with full movement of the body, with the ability to have actually touch-censored visual motion. And when you're dealing with senses are more than just the sight and the sound. When you move from a flat screen to a three-dimensional that you can move in and then add in the sensation of motion, you now add an entire new portion of design capabilities. Then add in the ability to process at a level that you couldn't process before, that you could actually get at least, not if in saying that machines understand something isn't really a true reality. Machines don't understand anything, but machines are able to process and provide feedback to users to give the appearance of understanding, and that is artificial intelligence. You just think that the machine's understanding it. So machines like IBM Watson. Well, Watson is able to beat Ken Jennings in Jeopardy by answering a number of questions, but Watson doesn't understand the meaning of any of those questions. Okay? Watson is just capable of processing that and providing an output based on a probabilistic this answer is going to have a higher probability of being correct than another probability of being correct. And it's an algorithm. It's a very complex algorithm. It is a very good algorithm. But that's not even important. What's important is that an AI interface like Watson gives people like doctors, if I can take thousands of medical journals and then process them through Watson, and then have Watson be able to say, well, can you tell me if the oncological results of this provide me a better outcome to my patient, or versus doing this, and Watson can look through hundreds of medical journals and tell me that with 90% probability that in the situation that you've got, this user is going to have a better outcome. That's stuff that that's a tremendous amount of work for a doctor to do that. And they're not capable of processing this level of information. So what AI has done, and systems like Watson has done, is it's provided us a capability of processing way more information than we could do by ourselves. And that's actually where we're going with these types of systems. And I'm going to leave you with a couple more here, the concept of personal robotics, because this is, again, we're talking about interface design. Okay, personal robotics is a field. Robotics is a robust field in an industry. I mean, there's no question about the efficacy of robotics in the industrial world. But what you haven't seen yet is the concept of personal robotics, robots that do things that you specifically need, robots that can care for people that are indigent or can handle simple tasks that we typically give to users. Okay, this is now a field that is working its way up, but personal robots need interfaces. Is it a visual interface? Is it an auditory interface? Do they act like people? Do they not act like people? I mean, the robot designs of the future aren't necessarily the robot designs that we see coming out today. We typically thought, hey, well, if we're designing a personal robot, it's going to be humanoid, and it's going to be a speech interface, and it's going to have hands and legs. Well, maybe not. Maybe that isn't the correct interface for people. Getting down to the goals and the tasks and the usefulness of the robot is what's important. And lastly, this is the most important slide of all. This is what you're going to fill in. You are the designers of systems in the future. You are the ones who are going to use personal robotics and artificial intelligence and new things that we're inventing today and making them the interfaces of the systems that we're going to use tomorrow. And we know this to be true because if you look at what you have today and then compare it to what you had 10 years ago and what you had 20 years ago, we are completely different people in what we do today because of the devices and the interfaces of those devices that we have now, that we didn't have then, and we didn't have back then. We're still the same people, but our capabilities and our ability for expanding the universe, or what we can do. I now have a small device that fits in my hand, which contains almost the conglomerate of all human knowledge directly at my fingertips. And I do use it to watch cat videos every now and then. But I also use it to get information and communicate. What are those interfaces going to look like? And how are they going to be designed? And how are they going to benefit us? That is going to be what is up to you and what you design. So in reality, what you're doing here with HCI is probably one of the most important fields of all because it is the field that will define where we go in the future. Dr. Ron Eaglin signing out from Daytona State College. Thank you very much.